In this video, we're going to be talking about proportional relationships. So first, what is a proportional relationship? A proportional relationship is a relationship between two variables where their ratios are equivalent. So the ratios have to be equal in order for there to be a proportional relationship. The other key term that we need to know in this lesson is equivalent fractions. So equivalent fractions, we have that key, the start of equal. So fractions that have different numerators and denominators but are equal. So let's do an example and put these vocab terms to use. On Sarah's favorite mobile game, she is awarded game lives when she finds gold coins. Sarah played the game 3 times and recorded the amount of coins and lives she was awarded. Write the information in the table as rates. Do these quantities represent a proportional relationship? So we know that she is awarded game lives when she finds gold coins. So the lives are going to depend on how many coins she has. So we have for 3 coins, she had 9 lives. For 2 coins, she had 6 lives. And then for 15 coins, she had, so for 5 coins, she had 15 lives. Now, one way that we can determine if these rates are proportional is to find the unit rate. And as a reminder, a unit rate has a denominator of 1 because you're trying to find one single unit. So in order to find the unit rate of how many lives she needs for each coin, we're going to divide. So this one, we have 9 divided by 3 is 3. So for 1 coin, she needs to have 3 lives. The second one, 6 divided by 2, also 3. So far we're off to a good start because those are equal. Last one, 15 divided by 5, same thing, 3. So this is proportional because it's saying for each time she had to have 3 lives to get 1 coin. So this is proportional because they are all equal. So that is one way you can find if you have a proportional relationship. The other thing that you guys can do, so I'm going to show you 2 ways so that you guys have 2 different ways in your toolbox to be able to find proportionality, but whichever one makes the most sense to you is the one that you should use, as always. The other way that you can do this is to use something called the butterfly method. So this is where we are going to cross multiply. So for instance, I'm going to just use our first 2 fractions first. I'm going to draw my little butterfly wings by circling my diagonals, and I'm going to use multiplication here. So that means I'm going to multiply 9 times 2, and I'm going to see, does this equal 6 times 3? And it does, because 9 times 2 is 18, and 6 times 3 is 18. So we can say those 2 fractions are proportional. So you can either use the butterfly method, where you cross multiply to see if they are equivalent, or you can find the unit rates and compare. So example 2, is the relationship between the area and the side length of the squares proportional? So first, we know that side lengths of squares are going to be the same. So I'm just going to go ahead and fill this in. The first one is 2, second one is 3, and the last one is 4. Now, if we don't remember area of a square, we do length times width. So for my first one, my area, 2 times 2 is 4. My second one, 3 times 3 is 9. And my fourth one, 4 times 4 is 16. So what I can say here is if I'm trying to compare my area to my side length, I'm going to go ahead and set up my rates. So now that I have those set up, I can go ahead and find my unit rates because I want to compare and see if my side length was 1, and am I going to have the same area, because that would mean that it would be proportional. So for the first one, if I do 4 divided by 2, I get 2. If I do 9 divided by 3, I get 3. And if I do 16 divided by 4, I get 4. So this is not proportional because these fractions are not equivalent. So they are not proportional. And you can also test yourself again by doing the butterfly method. If I just test out my first 2, 4 and 2 and 9 and 3, If I were to cross multiply here, I would have 2 times 9. And does this equal 4 times 3? It does not, because we have 18 cannot equal 12, so not proportional. All right, last one. The table shows side lengths and perimeters of regular hexagons. The relationship between the perimeter and the side length of the hexagons proportional? So we also need to be able to find the missing values here. So I'm going to go ahead and set my first rate. I know that when the side length is 2, my perimeter is going to be 12. I want to go ahead and find, since I do have some missing values here, I cannot use the butterfly method. So I'm going to go ahead and find my unit rate. So I know I'm trying to find my denominator of 1, which means I'm going to be dividing by 2 on the top and the bottom. So 12 divided by 2 is 6. So this means when my side length is 1, my perimeter is 6. So what this means is that when I had a side length of 2, I multiplied by 6 to get my perimeter of 12. So I know I can go ahead and multiply then my bottom. If my side length is 5, I know that my perimeter is going to be 5 times 6, 30. And now what I have is I know I have a perimeter of 18. So if I started with a perimeter of 6, what did I multiply to get to 18? I would have multiplied by 3. So I know I can say that when my perimeter is 18, my side length is 3. And you can also check now, are these proportional? I'm going to go ahead and do the butterfly method on this one just to change things up. If I have 12 and 2 and 18 and 3, let's do our butterfly method. So we have 12 times 3. Does this equal 2 times 18? Now, I'm going to use my calculator just to show you guys. You can use your calculator on this unit, although hopefully we know this off the top of our heads. But we have 12 times 3 is 36, and we have 2 times 18 is 36. So this one is proportional. And then our last one, just to check, so let's do 18 and 3, and we have 30 and 5. Cross multiply here. Let's see our butterfly method. Will these equal each other? 3 times 30. Does this equal 18 times 5? So 3 times 3 is 9. Tack on that 0, so we have 90. 18 times 5 is also 90. So yes, we have a proportional relationship here because our fractions or our rates are equivalent.